I guess I'll just show some stuff about what we've been up to in terms of sort of human AI interaction. And so the first demo I'm going to show here, let's see if I can share this one.
Okay, yeah, we see it.
So you can see this screen called Andromeda.
Yeah, I love this.
So this is a kind of a simple demonstration, but demonstrates the basic idea behind what a lot of we've been working on lately, of helping people sort through high-dimensional data in a way that enables them to interact with AI in the background, but in a way where they're, very much like you were describing, in a way that where it's a feedback process, right? Yeah. Where there's a two-way communication happening. And so this is what this demonstration shows is doing that with an example, kind of a fun data set about it's high-dimensional data. So this is a data set of a survey I took with students in my class. So here you see a bunch of names of students next to dots in the main plot here. And over on the right, you see these are the questions that the students were asked. Like the first one is, how many publications do you have? How many years of job experience do you have? How much do you like camping? Just sort of goofball questions like this, just for fun stuff in class. And so you can think of those as the dimensions of the data, and then the student names are kind of the rows of the data, right? The observations. And so what we're doing here is we're taking that high dimensional data, it's what, about 25 or 30 dimensions over here. We're projecting that down to 2D in this plot on the left, where students are near each other if they answered the questions similarly, right? So there's a proximity equals similarity relationship over here to project the high D down to 2D. So for example, you can see right away that I am over here and I'm very far from all the students. That means I'm very different from them, right? I'm an outlier in the data set in that sense, right?
I was going to ask, what happened to Chris?
Yeah,
it's way over on the right there, yeah.
So for example, like lots of publications, lots of years of job experience and so on, compared to the students, right? Yeah. Those are things that make me very different. But over here, it's also kind of interesting. You start to see some clusters, right? Like you see a group of names here that look kind of, sort of English looking, right? Whereas up here, you see a lot of names that are more, maybe Asian looking, right? So you start to wonder if these clusters are meaningful. Like, why is it that these nationalities have this sort of difference in all these other questions? And so you can start to sort of probe that, right? So one way you can probe that is by interacting with these dimensions. So I could say, well, let's probe this issue of distance. How far from Blacksburg, where Virginia Tech is, were you born, right? And so what I could do is I could kind of drag that to the right, saying put more emphasis on that variable, right?
Yes.
And as I put more emphasis on that, sure enough, those two clusters that I had hypothesized do indeed separate out, right? That those are people that are born domestically versus people that are born internationally, right? And so it turns out that variable is kind of you might call it a predictor of other variables in the data set, right? It's very indicative of those two clusters.
Now, if you had one that was how advanced are you in mathematics, you might see a very similar thing for the same.
Well, maybe. I've got one like that here, I think. Maybe that wasn't this survey.
Yeah.
No, I had here's one for computer science.
All right, there you go.
I thought I had one for math, but we could ask about like, how much do you like computer science was the question. So it's like a 0 to 100 scale.
Right.
And so we could kind of drag that and we could say, actually, there's quite a bit of mixing, right?
Yes, yeah.
Right? Those two clusters kind of merge and then separate, and you can kind of see a spectrum here of people that really like it to really don't, right? Over here is people that really like it, and over here is Dave really doesn't like it that much.
I object.
Right, that's,
I love it.
right.
Different Dave, right?
Different.
Yeah.
But the interesting thing here is I could ask the questions the other way around as well. As I might ask a question like, well, what would it take, for me to be in this cluster of my students over here? And actually,
How do I differ?
Let me start over. I want to do that a little slower, just so you can see it happen.
Yeah.
So I'm gonna drag myself over to this cluster and say, well, I want to be in this cluster of sort of, domestic students. What would make me be like them? Mo, on the other hand, he's kind of an international guy. I'll throw him up here with the international students. So I'm kind of building my own clustering based on what I know, right?
Yeah.
Or what I'm interested in. And then I can say, well, give me a layout where that's the case. You know, what in the data would support that? And so I can say, do a clustering, and it finds a clustering where that's the case, right? And so if I sort these, I can see that if I emphasize things like how much you talk on the phone, how far from Blacksburg you were born, there's that variable again, and how extroverted you are and how much you take photos. Those are predictors of this clustering I just made, where I'm in this cluster down here with the domestic students, right? And so I could look at that. I could look at these students down here, and sure enough, these are people that don't talk on the phone much. We were born nearby. We're pretty introverted, and we don't take very many photos, right? So that's kind of like the domestic crowd, where I'm part of, that's the way I'm similar to my domestic students, right?
So David, your wheels turning here. I mean, I'm wondering, Chris, if, as you'll see, I went through your documents and mine, and I created 7 categories. Could have been more, but I didn't want to make it too refined. 7 categories or dimensions of snippets, right? So anything that was central, focused on visualization got a visualization tag. Anything that was about sense making got a sense making tag. Things that were about the machine emphasis, machine analytics, got a machine analytics tag. And so then the idea would be, could the machine somehow represent the information that's in those documents that's been organized,
right?
To allow you to play with it, to see what happens when you move things around in terms of proximity, and so forth, or you bring in more categories or whatever.
And so maybe I can show you then, I guess, the next thing.
And this is what it meant to me, and maybe I need to update that anyway.
Yeah, it's great stuff. There's a ton of research.
Really.
So anyway, what I'm showing here is kind of we've expanded on those basic ideas I showed in the previous demo and into sort of the text analytics world. And so this is an example, like an intelligence analyst looking at a bunch of little snippets of intelligence information and using a big display to start to organize those bits of information into some kind of structure, right? Some sort of externalized structure. And we started by doing that just sort of in a manual way, where analysts can just sort of drag this stuff around the screen and start building these structures. But then we realized that, hey, we've got this opportunity now to add machine learning into the mix. We realized that, hey, as the person is doing this, they're actually externalizing useful information that we can learn from. And so then we built this series of systems called ForSpire and StarSpire and other spires that we've built that look more like, let's see, I'm going to skip down to another picture here, maybe this one, where as the analyst now is organizing these documents in a space, very much like you would sort of on your desk of just making piles and things like that. But in a digital environment, you're organizing things spatially, like you're highlighting things that are important. You're typing notes in the margin of annotations. You're doing searches to find additional information. All those things are watched and observed by the system and learned from and used to help. And so the system builds a model in the background that helps in 2 ways currently. One is that it helps in foraging for additional information out of a much bigger database and bringing that information forward onto the screen. So here you see that some of the documents or some of these snippets are shown kind of as like text windows, whereas others are shown as little icons in the background. And so these icons are things that are like recommended by the system that you would read. Secondly, what it does is then it helps to organize those things in the way that the user has organized them, right? So if the user says, oh, I think this document is related to that one, and kind of drags it over there next to it, then it's kind of like building a cluster. You're saying, oh, these things are related. And so then the system can learn from that, kind of like in the previous demo, and use that to query other relevant information and bring that onto the screen. And sure enough, some new documents show up in little icons here, sort of filling out that cluster that the user had started to build. And even some other things start to move around to sort of refine this space based on each interaction that the analyst does.
Are you using a similar algorithm as the first demo?
It's similar, but more complex.
I guess, yeah.
In the sense that it's using, text-based learning techniques, and it's doing multiple things. The first one was only doing sort of spatial organization stuff, whereas this one is also doing the issue of sort of querying and filtering information onto the screen that wasn't on the screen before, and that kind of stuff. Mm-hmm. So then you end up in this sort of collaborative concept that we call semantic interaction, which is the idea that you have this sort of externalization space that serves as kind of the common ground between the analyst and the AI, and the two can sort of understand each other through this space. Mm-hmm. And then you have this collaboration where the AI can sort of help the analyst in this task of gradually formalizing this collection of documents and formalizing some understanding about it. So I was just telling David earlier that the next step that we're working on now is, well, now that you've built this space and you've got some sort of structure constructed here, how do you then turn that into a report?
Quick question about the structure. Is that contextual? Like, have you laid some groundwork for, like, the way I always think about it in Highlighter is there's an anchoring question that drives what's relevant, right? Is there some kind of, is it that, or do you just look for it unbounded? Do you just look for clustering without an anchoring context?
I mean, it could be either. So we've tried this in a couple of different scenarios. Like one is, where you have some anchoring question, right? Where an analyst will say, okay, what are these terrorists doing now, right? Yeah. And they'll have some target, right, that they're going after. But another scenario is analysts who are just trying to keep abreast of their area, and there's always new information coming in, and they're just sort of trying to keep a kind of a notebook, a visual notebook of what's going on in their world, right? That they're responsible for. Yeah. And so they would be just sort of keeping a more general structure that they're useful. We've also seen analysts or scientists thinking that way in terms of literature that they're familiar with in the field, and sort of keeping a sort of visual notebook like this of how they think about the space of their field. So I see it as both kinds of scenarios, open-ended or targeted.
Okay.
The structure can be relevant in either way. Let's see, so what we're working on now is how you then would take this sort of two-dimensional space and turn it into a linear report, right? A written report, or in the case of analysts for the federal government, they oftentimes use PowerPoint, so a series of slides.
Right.
And so that's the interesting question we're working on now, is how you might then reduce this to 1D and then do extraction of the relevant pieces of evidence, the most important piece of evidence for use in that 1D, to help the analyst kind of create an outline of their structure that they would then fill in with more detailed meaning and so on as they kind of interact with the space in order to create that meaning.